I'm no longer on the subcommission now, but Jim Barrick is, and he's getting together with Chinese colleagues, and we're correlating a very few of these conodont forms, morphotypes, have been correlated into southern China. So we get a picture of what this environment was on a worldwide scale, and in all these places we have what we call cyclothems, which are these packages of marine transgression, high stand, and marine regression deposits stacked on top of one another all around the world. But it's in this mid-continent area from Des Moines, Omaha, down to Kansas City to about the Oklahoma border that they are so distinctive that they can be readily recognized. And that's because we had the right physiography of the continent to get low oxygen water during the maximum transgression. And these black shales make this almost unique. They hadn't recognized these cyclothems in the Moscow area because they didn't have the black shales in them. All they had were the paleosols, and they didn't realize, because they were in a much drier climate, their paleosols were real thin.
Right.
And they didn't realize there were paleosols until just about 15 years ago. And now they realize they've got the same kind of things too. Sea level rise when the glaciers melt, sea level falls when the glaciers build up. Because that's one thing you can tie in on a worldwide basis when you have glaciation of that scale.
Dr. Eckel, do you know how much time would be elapsed between this black shell and this one?
Okay.
Are we looking at
we've done some what we call calibration of the time scale. We got a few radiometric dates, not much in North America because there wasn't any volcanism here, but in the southern Urals. And they have got some radiometric dates from the southern Urals, and we take these conodonts and correlate into their succession in the southern Urals. And we find that we can group little cycles and big cycles around these major cycles that have these black shales. Roughly 400,000 years, which is one of the big long eccentricity orbital parameter of the Earth. And so between this black shale and that black shale, we'll say around, give or take 100,000 years, around 400,000 years. Because what we've done, and they just did it independently in Ukraine now, is we take a couple of these dates and then we count the number of major cyclothem groupings in between, and we find out that they fall into 400,000 year patterns. And in the Ukraine, an article just came out this year, and they have different cyclothems in the Ukraine, but they still have high stand limestones there. They don't have black phosphatic shales. High stand limestones and low stand sandstones and terrestrial deposits and paleosols and stuff like that. And they came out almost exactly the same number between a radiometric date and a radiometric date. We had 18, they had 20, and you're dealing with 300 million years ago. That's not too bad.
Yeah, and also just to give an appreciation of how high evolutionary race these conodonts have is that you're getting different forms within like 400,000 years.
Yeah.
Now to put it, what's going on in the Pennsylvanian is quite similar to what's going on today. This is an ice house planet because we had glaciers on the southern hemisphere. We're also in an ice house planet, except the glaciers are concentrated in Antarctica and in the northern hemisphere, like in Greenland and the Arctic. And we also have, again, these are examples of changes from ice age to interglacials. And right now we're in an interglacial period, and eventually we'll go into another ice age. Right, so when you have an interglacial, glaciers melt, sea level rises. So this is an example of a sea level rise, and then when sea level falls, as the glaciers have built up, and so this would be like an ice age, or during that time, because the glaciers have built up, sea levels fallen, this is exposed dry land. And that's kind of what's going on now. I mean, people are talking about the glaciers melting, sea level rising. So similar forces at work now are at work in Pennsylvania. And of course, Iowa is at a different latitude. We're not covered by an epicontinental sea or a sea that covers like a continent. So there's things are different now from the past, but in terms of the glacial eustatic signal, it's the same as what's going on now. So the Pennsylvanian and the Quaternary are identical in that sense.
Can you describe these conodont animals a little bit for some of us younger ones?
Well, the only way they find them, they had apparatuses. They didn't have individual teeth so much as they had apparatuses in which they had two platforms, sort of shovel-shaped elements with ornamentation on the top that sort of ground together. And if you know something about ecology, you have the primary producers, the phytoplankton, and then you have the zooplankton that eat the primary consumers, the zooplankton that eat the phytoplankton. And then you have the third trophic level, which would be the secondary consumers. They're eating the zooplankton, they're eating the phytoplankton, and we figure, I should say we, the people who really study this, I don't, I just do what they write about, is that these had, there's a number of them. Some are tusk-like, but we don't use them for biostratigraphy. We use these platforms that they ground stuff up, and it looks, they've got enough of an apparatus, it looks like they're going after the primary consumers, meaning these are at the third trophic level or secondary consumers, and they're going after the zooplankton like copepods and that sort of thing that are eating the phytoplankton. Now some of them may have been taking in phytoplankton, that sort of thing, but the type of apparatus that it looks like they've got is more likely eating zooplankton. They had to chase and grab and
so there's
grind up.
organisms of some sort.
They are little worm-like organisms that long with the teeth on the order of a millimeter or less.
See, I drew a rough picture. They're they're worm-like. They're veriform. Some of them, the reconstructions have big eyes. They're kind of cute. They got these little big old bug eyes. They're based. Any evidence?